Here, we're going to solve linear equations with 2 steps. Solve the following equation for the variable. So again, our variable here is x, it's the unknown quantity. On the left-hand side with x, we have addition and multiplication. So we're going to have to undo both of those. That's why it's a 2-step solution. We want to get our constants on one side and the linear terms on the other. So I'm going to move 7 to the right. And the way I do that is I subtract 7 from each side. And this kind of plays back to the additive inverse principle we brought up earlier. So I'm subtracting 7 from each side. That's going to cancel out the 7s and leave me with 2x equals 12. I still need to isolate our variable x. And since it's being multiplied by 2, I'm going to divide both sides by 2. That'll cancel out the 2 with the x. And I'm left with x equals 12 over 2, which we know is 6. Here's another example, x plus 30 equals 4x. So what's different and new this time is that we have an x, or the variable, on each side of the equality. So I'm still going to have the same goal of getting constants on one side and linear terms on the other. I'm going to go about it a little bit differently. I'm going to move an x this time. So I want to get the x's together. I'm going to move the x from the left over to the right. You could have moved the 4x over, that's fine. But what I'm going to do is I'm going to subtract x from each side. And so what I'm left with is 30 equals 3x. And so now I have constants on one side and linear terms on the other. And then since 3 is multiplied by the x, I'll need to undo that. So if I'm multiplying, the undo is division. I'm going to divide both sides by 3. That's going to isolate my variable x on the right. And I'm going to be left with 10 equals x. In this equation, we have linear and constant terms on each side. But it's still my goal to get constants on one side and linear terms on the other. I'm going to move 2x. I'm going to move the negative 2x to the left by adding 2x to each side. So it's negative 2x. To undo that, positive 2x. So on the left, I'm going to end up with 6x. But on the right, my 2x cancels out, or my negative 2x cancels out, rather. So what I'm left with is 6x plus 8 equals 11. But I'm still in a position where I have constants and linear terms together on one side. So I'm going to go ahead and move the 8 over by subtracting 8 from each side. And this cancels out the 8 on the left so that I have a linear term 6x on the left, and I have my constant term 3 on the right. So now I can go ahead and divide by 6 on both sides to cancel out and isolate my variable x. On the right-hand side, I have 3 over 6, which I can reduce to 1/2. And in my last example, it looks very similar, but the answer is a bit different. So here we have linear and constant terms on each side. So I'm going to do the same approach as before. Except this time, instead of moving a variable first, I'm choosing to subtract 3 from each side, which you're welcome to do. You can start wherever. As long as you're making a mathematically correct step, it's not wrong. So if I subtract 3 from each side, notice they both cancel. So now this is very interesting because what we have is 4x equals negative 2x. And this feels new and weird, even though we started off with a very similar equation. But we can kind of still blindly apply the rules here. I still want constants on one side and linear terms on the other. And 0 is a constant, so I can add 2x to each side. So by adding 2x to each side, I'm going to cancel the negative 2x. So what I'm left with is not just a blank, it's actually the number 0. And so I have the equation 6x equals 0. And this is totally fine. I can keep moving forward as I've done in the past, dividing each side by 6. That gives me the cancellation of 6 and allows me to have an isolated variable x. And on the right-hand side, I have 0 over 6, which is fine. This is a number and its value is 0. So the answer here is 0.